All right, we're going to look at the factor theorem now. Factor theorem that we're going to use to work with polynomials and factor them, break them down. To start with here, you need to think back to a previous math course or previous work where you learned to factor quadratic expressions, right? Something that's x squared. And trinomial specifically, something x squared, something x, and a constant term on the end there. When you learn to factor those, probably did it in several steps. You're learning, but in the end, you got to the point where you could just break that down into two factors. And you learned pretty quickly to follow a pattern, and the pattern just comes from multiplying it out. But you found that the pattern was there can be two binomial factors if you have this x squared, x, and a constant term. And you also learned that, well, if the first term's x squared, they're going to start with x. And then you likely learn to zero in on that last term there. That last term being 12. There's a lot of different possibilities, right? These two numbers could have been a lot of different things. They could have been 3 and 4. Okay, you could try 3 and 4, 2 and 6, 1 and 12, but it's got to be some combination of those. There's no way one of these can be a 5 or anything like that. All right, so you probably got pretty good at that, and we might as well figure this out here that I'm going to say it's 6 and 2 because I'm looking at the difference there is 4, and it's got to be that. Those two factors multiply out to x squared plus 4x minus 12. What we're going to look at now, though, is what if you were looking at a cubic or higher instead of a quadratic? How are we going to find those factors? Because it's not going to quite be as easy as what we have here, right? This is a trinomial here that you get from multiplying two binomial factors. If we have a cubic here, such as this one, if we're looking at factoring that cubic, think about how many factors might that have? Well, if the first term is x cubed, this is possible that it's going to have 3 factors here, like that. Right? And if the first term is x cubed, all 3 of those factors are going to start with x. But here's the hard part is, what are those numbers? All right, because this is not so simple as before where we can just, look for a pattern, and when you have 3 going on here, think about how you would multiply those out. If you had the 3 factors, you'd multiply, say, those 2 out to give you x squared something, and then you'd have this one, and you'd have to multiply this one out to get x cubed and the rest of it. So it's going to be hard to just kind of do it by looking at it and seeing what those factors are by kind of educated trial and error. So we're going to need something else here to do this. We need to think about what the possible factors are of this. All right? It's still going to have to do with that last number, that constant term, just like it did for quadratics. Possible factors here, number 1, there could be 3 factors total if it factors. And number 2, they're going to look like this, x plus or minus something. And the something's going to have to do with that number. If that's a 10, the numbers that we're looking at here have to be factors of that number. Just like before, for that quadratic, the numbers that were in here have to be factors of that 12. So if I go down here, here's my possible factors. It could be x plus or minus 1, x plus or minus 2, x plus or minus can't be 3 because that wouldn't work here. Can't be 4 or 5. It could be 5, or it might be x plus or minus 10. Those are the only possible factors. That thing has 8 possible factors. It's not going to have 8 factors when we break it down. At most, it can have 3, right? Because you have x cubed here. So how are we going to figure out which ones of those it is with the goal of being able to factor this thing? Well, let's move these possibilities out of the way for a second here. We'll save those right over there. So how can we check which ones of these things are factors, if any are factors? Well, it has to do with looking at when you divide it, does it go in evenly? That's what it means to be a factor. If I do 20 divided by 4, it gives me 5, but the key is here it gives me a remainder of 0. There's no remainder. If I did 21 divided by 4, I'd get 5, but I get a remainder of 1. 4 is not a factor of 21. For something to be a factor, you need a remainder of 0. So what we need to do is look at what the remainder is. And we've already looked at how we can find the remainder quickly. say if we were dividing by x minus 1, if we want to know, is this a factor? So I'm going to put that question mark, is that a factor? We can find this by finding the remainder. And the way we're going to do that is we're going to sub in x equals 1. If you sub in x equals 1 there, okay, so I'll make a list here. X minus 1. If we sub in 1 here, we get 1 cubed plus 4 times 1 squared minus 7 times 1 minus 10. What does that give us for a remainder here? This is 1 plus 4 minus 7. 1 plus 4 minus 7 minus 10. This is definitely not equal to 0. It's equal to something much lower than that, negative 12. Not 0. This is not a factor. Right? That is not a factor of that expression. Not 0. Not a factor then, right? So we got to try something else. What else could we try? We've got 8 things here to try. We tried x minus 1. How about if we try x plus 1? Let's try x plus 1. Is that a factor? Now, if we want to try x plus 1, we got to sub in x equals negative 1. Root of that divisor, right? Remainder theorem says if you put in the root of that divisor, it gives you the remainder. So if we put negative 1 cubed plus 4 times negative 1 squared minus 7 times negative 1 minus 10, and see what that equals. All right, we got negative 1 plus 4 plus 7 minus 10. Let's see what that gives us. All right, what does that give us? We have 3, 10, minus 10, 0. This does equal 0, right? When the remainder equals 0, remainder equals 0, therefore, x plus 1 is a factor. All right? That is a factor. If you have the remainder being 0, then that thing has to be a factor. When you sub in negative 1 and you get 0, it means x plus 1 has to be a factor. All right? So that's one of the factors. Now, the original question I had here was, how can you factor a cubic? Well, there's only 8 things that it could possibly be. We could sit here and try all 8 of those. But once we've found one, then what we can do to speed things up here is we can just divide it to see what's left. Right? So if we can, the strategy is then, if you can divide it, if we know that one of them is x plus 1, we could divide it to get what's left here, because we expect what's left to be x squared and a couple other terms here. All right, so if we divide it, we'll see what's left. So let's do that right now. So we know that x plus 1 is a factor here. So if we divide this out, put our plus 1 here, we put our coefficients of our original polynomial, 1, 4, negative 7, negative 10. And we do a quick synthetic division to see what we get here. Now, we expect that this was going to be 0 because we already found that it was 0 up here. And now we're interested in the quotient. Before we were just interested in the remainder. Now we're interested in the quotient. So we already had our factor here, which was x plus 1. But now we know the rest of it. Right? We know that that original polynomial can get broken down into these two things here. X squared plus 3x minus 10. So we have those two things. Now it's a lot easier, because if you know this one factor, and you hopefully already know how to factor quadratics like that just by trial and error, educated trial and error, or some other method, we know that we could try and see if this will break down. And we can probably break that down. Again, it has to do with that last number. So we're going to try things here, and it looks like that is it. Those are the 3 factors of that original polynomial. You're breaking it down in a several step process, but the first step is is definitely the most time consuming, right? Starting with x cubed plus 4x squared minus 7x minus 10. To get to that first step of having one of the factors and then what's left takes a long time, but then once you've got that, that last step is a piece of cake. All right, so that's how to factor polynomials. Now let's summarize a little bit of that stuff that we've seen in doing that. The factor theorem. The factor theorem is a formal way of saying the ideas that we just used. We looked for factors by substituting in numbers. We found that since when we subbed, I'm just going to use p for the polynomial. When we subbed in -1, it gave us 0. When we subbed in +1, it didn't give us 0. Right, it gave us -12 or something like that. When we subbed in -1, it gave 0. It meant that x plus 1 is a factor. Now that's what the factor theorem says. It says if you sub in a value a, in this case here, in the way this is written out, if you sub in a value a and get 0, then x minus a has to be a factor of that polynomial. It's a special case of the remainder theorem. The remainder theorem said if you sub a number in, you get the remainder for when you're dividing by x minus a. If you happen to get 0, then you know that there's 0 remainder, which means that's a factor. All right? So let's bring this up here. In other words, if you substitute a value into a polynomial and get 0, then you know a factor of that polynomial. You've found one factor. And once you've found one factor, you can break down the rest of it. All right, so let's look at that one. That one's a quartic, degree 4. So it's going to mean that we're going to have to do we're going to end up with a possible 4 factors in the end here. 4 binomials at most. And we have to start looking for them. Again, it's going to have to do with this number on the end. So we'll try our numbers here. Possible factors, x plus or minus 1, plus or minus 2, 3, 4. Factors of 24, right? 6, 8, 12, 24. Lots of things to try. We'll start with the easy ones, 1 and -1. If we are going to try to see if x minus 1 is a factor, we're going to sub in 1. 1 to the 4th. Subbing in 1 is just basically looking at the coefficients here. 1x to the 4th is going to be 1 plus 5 minus 10, right? Because subbing in 1 doesn't change anything there. Minus 20 plus 24. If you add that up, 6 gets you minus 4, minus 24, 0. That does equal 0. So this is one of our factors here. Right? That's one of our factors. Now we could continue to look for factors all the way down this list. That might be kind of tedious. Once we know one of them, let's divide and get to where we're going here a little bit quicker. Put our original coefficients, 1, 5, -10, -20, 24. We are dividing by x minus 1. So we can do this pretty quickly, hopefully. And we get 4, -24, 24. Subtract, we get 0. Again, makes sense that that's 0, because we already know that. And then let's proceed from there. This is our quotient. So we already have our one factor. I'm going to write it down here. X minus 1. And then our quotient here is a cubic, x cubed, plus 6x squared, minus 4x, minus 24. So we've got our first step there. Now, unfortunately, we're going to have to do that again by testing some numbers to find what could possibly be a part of that, right? Because we can't break it down to just by looking at it, right? By inspection or by testing, by trial and error. So we've got to look again here. We're going to test another number for what's a factor of this, right? We already tried x minus 1. Now, that doesn't mean we can't try x minus 1 again, because it could have 2 of the same factor. So since 1 is so easy, I'm going to try that again. I'm going to try to see if x minus 1 is a factor. So I'm going to sub in 1 into this simpler part of it and see what I get, right? 1 plus 6 minus 4 minus 24. Definitely doesn't equal 0. I'm not even going to bother adding it up because that's way too big. So then we're going to try x plus 1, see if that works. Now, x plus 1 is easy to sub in because when you sub in a negative 1, it's going to be those same coefficients, but their signs might be different. When I sub negative 1 in, I'm going to get negative 1 plus 6 minus 4 times minus 1 is plus 4 minus 24. Let's see what that gives us. That definitely, again, does not give us 0. And I should have recognized that before, because no matter what I do, no matter how I change the signs of that, they're not going to add up to what we want, which is 0. So I'm going to try x minus 2. X minus 2, let's get rid of my circles up here, and we'll try to see where we are. 2 cubed is 8. 6 times 2 squared is 24. Negative 4 times 2 is minus 8. Minus 24, that's already looking pretty promising because you can see that that's 0. When you find when you find the second factor here, now we can divide what we had, right? This, because we already took out that one factor, and we're going to divide that other part out. So I can divide that. I'm going to do my minus 2 here, but I'm going to divide this part right here, because that's the part I'm trying to break down. I already got that other factor out of there. 1, 6, negative 4, negative 24. Now we'll quickly do this. 1, negative 2, 8, negative 16. That gives me 12, negative 24. 0. Again, we knew it's going to give us 0. Expected. Once we have that, we can even carry this whole thing down. I'm going to carry that x minus 1 down because I found that first. Then I'm going to carry this down, x minus 2, and take the rest of my quotient here. X squared plus 8x plus 12. At that point, you're home free once you got it down to a quadratic, because we can break this apart. X plus, and it's got to give you that. So it's 6 and 2. And then you have it. All right? So that's it. That's the factored form. Now you could always multiply that out to double check that it equals what you started with long before here. All right? But that's the way you take something that's this. One single big huge polynomial. You first break it into a binomial times what's left, that cubic. And once you get your second factor, you got 2 binomials out. You got a quadratic left. And then you got your 4 binomials. Now, it's not always going to factor all the way down. It could have easily ended here where this was not factorable. Or even it could have ended where this was not factorable. Not everything's going to factor all the way down. I've picked a couple questions here where it does factor all the way down, but no, it's not always going to be that way. All right? Let's look at one more problem here before we're done. Another one of these working backwards type of problems. Right? This one tells you a factor, but you're missing a number in the original polynomial. So a good strategy for that is always try to write an equation based on what you know. If this is a factor, then you know that if you sub in the root of that, x equals 2, it should equal 0. Okay, so you can sub in that value and see what you get. So I'm going to write my equation like that. I'm going to sub in 2 here, minus 3 times 2 squared, plus k times 2, plus 6, and I know that that's supposed to equal 0 if that's a factor. So when I work all this out here, 16 minus 12 plus 2k plus 6 equals 0. Or if I bring everything all over to the other side here, move my 6, move my 12, move my 16, I got 2k equals minus 10. So that tells me that k is equal to minus 5. right? Find that way, that working backwards. But it's still using the factor theorem, knowing that when you sub in that value, it should equal 0 if it's a factor. All right? Well, that's it. That's using the factor theorem in a couple different ways there. Factor theorem again being sub in a value, get 0, you know a factor of that polynomial. All right? That's it.